So let's do the same thing, but with radical functions. So when we have a square root, some things to notice is that we start at the origin, so that'll be an important point. And then you could think of, if we plug in, like, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. That can give you a few good coordinates to start working with as you go through the transformations. Even just those three are perfect. So our domain's going to be limited with these because of the square root, so it won't be defined everywhere, and same thing with the range. So how you can visualize it is it's half of a parabola on its side, so it does have the shape of a parabola. We just only have a piece of it because we can't plug in negative numbers. However, with the cube root, we can plug in anything and get everything out. So what you can notice is the cube root is the shape of the cubic function. So as we talked about in the last video, your cubic function goes like this. This is the cubic function on its side. So they're directly related to each other. So with that, some key coordinates here. So we go through 0, 0. We have those 1's values. And then with cube root, out at 8 can be nice. So 8, 2, negative 8, negative 2, having those coordinates will kind of be key values to work with. Alright, so let's try this out. I'm actually going to adjust this a little bit. Instead of 8, let's use 3. Vertical stretch of 8 will just go too far. Okay, so because I can see the cube root of my variable, what I'm thinking of is my basic function is the cube root of x. So if I want to get a general sketch going, you can get that started. 8, 2, negative 8, negative 2. So with that, you can tell what function we're starting with. And then for transformations, this is all going to be compressions and stretches. With that 3 right there, it's going to be a vertical stretch by 3. With that negative 4, there's kind of 2 pieces there. We're going to reflect over y, and it's going to be a horizontal compression by 1/4. Okay, vertical stretch by 3. We're going to take these vertical distances and multiply them by 3. So where we were at 1, 1, now we're at 1, 3. At 8, 2, now we're at 8, 6. And same thing on the negative side. Negative 3, negative 6. So that stretches out our graph pretty nicely there. Okay, we're going to reflect over the y-axis. So what we're going to do is kind of this direction. So we're going to go across. So where we had negative x values, they're going to be positive now, and positive x values will now be negative. So where I have negative 8, negative 6, now I'm going to have positive 8, negative 6. So the y values stay the same. And then negative 1, negative 3 will now be 1, negative 3. And we'll still have the origin, and over there, and then 8, negative 8, positive 6. So that, there's our reflection. And then our last piece, which I know is getting messy, and again, you can delete pieces as you draw them on your paper. I just want to make sure you can see all the steps. Our next piece is a horizontal compression by 1/4. So I'm thinking about this like horizontal distance of 1, I'm dividing that by 4. Horizontal distance of 8, dividing that by 4. So it's like I'll have 2, 1/4, 0, 1/4, 2. So this is going to make it really long and skinny. So something like this will give us a little sketch to get started with our work. Again, it doesn't have to be, like every point doesn't have to be perfect, but follow a few points to get a general shape going. Alright, our last one here, the square root. So my square root function starts at the origin and goes off only to that first quadrant there. So in here I have a horizontal stretch by 3. And here, since that's outside of the square root, that's a vertical change, so we're going to be going down 2. Okay, square root function, we'll have 0, 0, 1, 1, 4, 2, 9, 3 to get a sketch going there. Horizontal stretch by 3, so the origin's going to stay in place. Here where we have this distance of 1, now it's going to be a distance of 3. Here where we have a distance of 4, now it's going to be a distance of 12, which I can't even graph on here. So this is going to make it really low. Like that. And then we just need to move down 2. So down 2, down 2. And then I just won't cross the x-axis there. Oh, I don't need to make it dotted. Something like that will be our transformation. So that's what we do with our radical functions.